Hey, welcome back to another junior measurement video. In this video, we're going to chat about the volume of a pyramid. Right, so we know so far the volume is the amount of space inside a 3D object. In this first video, there's one of two for volume of pyramid. We're going to focus on a square-based pyramid, which is what the Great Pyramid in Egypt is, a square-based pyramid. Historians believe that the Great Pyramid took up to 20 years to build. It was basically a tombstone or resting place for one of the emperors. Not a bad resting place, eh? Okay, pyramid is a 3D shape that has a 2D base, and all vertices on the base connect up to a point called an apex. So here is our pyramid we're going to look at. We're just going to draw in the hidden lines that we often can't see. We have this base here, a two-dimensional base. We'll come back to that shortly. But all points meet up at the apex. So all these vertices on the base rise up and meet at a single point called the apex. The height is basically the distance from the base up to the apex, straight up vertically, perpendicular to the base, 90 degrees. So let's come back to the base. The base, I know it doesn't look like it's a square here because the way I've drawn it, it looks like a rhombus actually. But if I look straight down on top of a square base pyramid, the base is actually a square, which is why we call it a square base pyramid. All right, so let's take a square base pyramid and talk about rectangle based pyramid, triangle based pyramid, pentagon based pyramid, or circle based pyramid. They're all pyramids. They all have a 2D base and everything rises up to a single apex. All right, well, here's the formula we're going to learn in this video and the next video. The volume of a pyramid is simply equal to the area of the base. We've got to calculate the area of the base. We've got to multiply it by the height and then divide it all by 3. All right, let's put it into use. Let's go with example 1. Calculate the volume of the following pyramid. So it's a square-based pyramid, so the base is a square, 15 centimeters by 15 centimeters. The height of the pyramid is 9 centimeters. So we know the volume of a pyramid is area of base times height divide 3. So we're going to go 15 times 15 times 9 divide 3 because we know the base is a square, 15 times 15. And the height is 9. So that's why we've got 15 times 15 times 9, all divided by 3. Now I like to just chuck it on the brackets. Anything I do on the top of a fraction I put in brackets. So I'm going to go, if there's more than one thing, so I'm going to go bracket 15 times 15 times 9, close the brackets, divide it all by 3, and I get 675 centimeters cubed. Now we're talking volume, we're talking cube. Remember, 1 centimeter cubed is a tiny little cube that's a centimeter by a centimeter by a centimeter. And if I have 675 of those little cubes, it would take up the same space as that pyramid. All right, well, let's get to the Great Pyramid. This is all exciting for me. We're going to calculate the volume of this Great Pyramid. So scientists have measured the base and to be almost perfectly square. So this example is not 100% accurate, but it's close enough. And it's pretty much 230 meters by 230 meters. The height of the pyramid is 147. That's what they think it should have been when it got built. So volume of a pyramid is area of base times height divide 3. We know that the base is a square, 230 times 230 to work out the area of a square. Times that by the height and divide it all by 3. Grab my calculator. That gives me 2,592,100 meters cubed. That's the volume of the pyramid. Now, what does that tell us? That we have these 1 meter cubes. Think of a cube that's 1 meter by 1 meter by 1 meter, a really big cube. This would take up the same. I'd need 2,592,100 of them to take up the same space as the Great Pyramid. All right, well, that's us done. So thanks so much for watching.